Here in Toronto, a revolutionary product is quietly unfolding, one that can change how we build with wood. We're at the headquarters of Nucap Industries, and for the past 25 years, they've been perfecting a technology that reinforces wood and upgrades the possibilities of what we can build with it. I'm Brady from the Mass Timber Group, and along with my business partner Nick Wilson, we're getting an inside look to see how GripMetal is upgrading the strength and unlocking low-grade fiber utilization in wood-based construction materials. Before we tour the factory, you need to first understand what GripMetal actually is. For people who haven't heard of GripMetal, what is it?
GripMetal is thin gauge sheet metal with thousands of hooks on it. One way to describe it is surface modification. So we're able to take thin gauge steel, aluminum, stainless steel, and modify the surface by adding thousands of hooks to the material.
But here's what makes it different from other types of connections like glue. When you press GripMetal into wood, those hooks don't just grip the surface. They penetrate deep into the fiber structure and essentially move that bond line into the material itself.
The hooks themselves, we're able to control the geometry of the hook, the amount of hooks that we're pressing into the wood. And when we press that in, what's happening basically is that it acts like a staple. The hooks are going in opposing directions. So as one presses in one direction, there's another going in the other direction. So they're opposing directions and locking that material into the wood.
Think of it like rebar and concrete. Rebar reinforces concrete by giving it tensile strength where concrete is weakest. GripMetal does the same thing for wood, transferring metal strengths directly into the wood product without relying on adhesives. Just a pure mechanical attachment solution. What we're looking at here is basically bonding metal into very different types of materials. And what it's able to do is take the properties of metal and transfer them to wood. So like, when's the last time you could take a wood board and bend it like this? As you can see, this veneer is pressed into the wood with these tiny little micro hooks. And so if we take a look at what this material actually looks like, so like this, a very thin sheet of this is what's bonded in between these two veneer layers. And if somebody was using this in, let's say, a highly custom application where they needed different material thicknesses, different lengths, widths, shapes, or whatever, you guys have the ability to cut and test that here at the R&D facility and then get that out to them?
We do, yeah. We have full capability to run. Like I said, we can run aluminum, steel, stainless steel. We've even put hooks on titanium. Any gauge or width is possible. We have tooling now that can build GripMetal sheets up to 4 feet wide.
Before GripMetal was ever used for wood, it had to survive one of the harshest, most demanding environments with the highest safety and performance standards: automotive braking.
GripMetal came from the NRS technology. NRS technology, which is won the PACE award in automotive, which is basically the safest technology to use for brakes. With NRS brakes, you have a bond for life. We have 1 billion in-use, in-field NRS brake pads without one single failure.
Yeah, and like I heard you talk a lot about like thermal cycling, right? So it's like increased moisture, decreased moisture, increased heat, cold.
Absolutely.
You can swing all those different ways without any material failure.
Absolutely. So what we'll do is we'll put the product test on these dynos, get into some extreme temperatures, try to, first of all, get it under extreme stress for heat and pressure, and then we'll take it right to the corrosion chamber, see how it's performing after that. Most of other brake pads will not last through that cycle because they're painted or they're glued on. But with our mechanical attachment, we always come out on top. That's why we feel so confident in using GripMetal in other structures.
As we were touring their facility, they showed us how they've already proven the mechanical attachment system in wood with a simple yet innovative modular building system known as EZBlocks.
To build an EZBlock, basically you're taking a raw piece of wood, you're going to run it through the milling machine to get it dimensionally correct, and then we take it over here and we're just going to cut it to length. An EZBlock's 20 inches long, 10 inches wide, and 7.5 inches tall. What happens here is the pieces of wood are loaded into the fixture. There is GripMetal in every row. So you got it on the bottom, you got it in between each one, and then on the top. And it's put through the press. It's loaded into this fixture, put in the press, and then pressed together. And it's a very, very quick operation. When a line is running at full capacity, you're making upwards of 500 blocks in a day easily.
Their EZBlocks have been used for restaurants, events, art installations, retail stores, and even DIY home projects. EZBlocks is a proven concept for GripMetal technology. But behind the scenes, they're working on pushing the envelope on something much bigger.
And so you guys are exploring how to bring this material into the mass timber world, whether that's CLT, NLT, Glulam. What have you guys been doing so far to kind of explore that integration?
Yeah, we've been working with a number of partners globally to look at the ways that by adding metal to CLT, a Glulam, you're able to improve the strength, reduce the amount of wood that's required, increase spans, even looking at using different grades of wood, so less expensive wood to achieve the same strength or greater strength.
Can you tell me like what kind of tests you guys have run to date and kind of like what you're looking at doing moving forward?
Yeah, we've worked with, like I said, we worked with a number of partners. We have a test facility in Innsbruck in Europe that have been testing GripMetal exclusively now for upwards of 5 years. They've been looking at different applications in terms of improving joint strength by introducing GripMetal in joints in mass timber structures in combination with grooves. They've been able to achieve 200-300% improvement in joint strength, which is allowing them to go higher with mass timber structures. More stories.
Their testing started in Europe at the University of Innsbruck, and in partnership with EZBlocks, they received a European technical assessment for sharp metal, an extension product of GripMetal made for timber-to-timber connections without glues or epoxies. Now their research is advancing here in North America with the help of Zenon Radowich with WZMH Architects and Sparkbird, an active R&D lab working on innovative solutions for the built environment. We met up with Zenon to learn about the application of GripMetal in mass timber assemblies.
Because this is an R&D lab where we do R&D work, when we heard about it, we felt it's a great fit for kind of what we're doing right now in terms of looking at how to integrate, technologies from other industries into kind of our architectural industry, right? So we're kind of big on that, where we're seeing there's a lot of opportunities to kind of bring on board other industries and commingle with them in our industry to kind of produce better results, right? So I think there's a lot of opportunities when you use GripMetal, combining it with mass timber to reduce the amount of wood that we use, to allow us to use new wood products that we could not use before, or existing parts we could not use before, right? There are markets in Canada, regions in Canada where their wood simply cannot be used, right? Where maybe they cannot use their wood, right? So I think that's really important.
Longer spans can enable mass timber to be used for data centers and warehouse projects without the need for deep supporting beams. Greater shear forces, tensile strength, and ductility can improve structural performance in failure modes and make mass timber more competitive in these spaces. GripMetal doesn't just improve the strength of mass timber components, it also enables lower grade species of wood and boards to be used in place of the expensive, slow-growing, premium-grade wood species and lumber inputs. We were curious to see for ourselves how GripMetal worked with wood and can enhance structural performance, so we decided to test it out for ourselves.
We're testing beam layups here using GripMetal and how we can use different grades, different qualities of species, and hopefully still achieve the same strength rating. Nick, you're in the lumber industry. Tell me what grades you think that these different boards are.
I would imagine right here, you have some Wayne. Yes, it's relatively straight, but I would say this is maybe like a utility grade. And normally when you get like into like 2x6, you start going into like number 4, number 3, number 2. I mean, this is a great stick of wood here. See, pretty smooth, pretty straight. This would probably be an easy number 2. You have some bow. This is gonna probably number 2 or stud grade or a utility. You got some, I don't know if this is gonna pass for number 2, but you're right there on the brink. Number 3 type thing.
All right. So what we're looking at doing is seeing how can we introduce a strip of 40 millimeter GripMetal. This is steel. What does the property do inside of reinforcing these lower grade boards in terms of structural beam performance, right? So we'll go through and we're going to lay up different configurations of this. So we're going to look at reinforcing the underside of the beam, and this is a test beam, right? We're not making full scale beams here, but in the tension zone towards the bottom and in the compression zone at the top. And then we're also going to laminate all these beams with the grip in between. And then we're going to take it down to Toronto Metropolitan University and break it and see what the values are.
We took our rough mock-up of a Glulam beam to the Toronto Metropolitan University research facility to see what kind of forces it would take to break it. We asked Dr. Sobi Masood, a structural engineer with Salis O'Brien, who's working with the testing team at TMU, where he sees the biggest performance gains with GripMetal reinforcing wood.
It's like basically the flexion and shape. The biggest challenge we had when we tested it like this axis and putting the GripMetal like this, it peeled off right away in the bottom. The thing is, we tested adjusted its own. There was no floor, nothing.
Okay.
But then we flipped them like a floor action, like a floor behavior, and definitely the results went way up.
It was way up?
No, you really get the gain because when you act it as a floor.
Yeah.
And that what you're doing here is almost, again, if you saw that with the test matrix we're planning to do with the CLT, that's exactly what we're doing. So like a layers of CLT, GripMetal in between. So which is exactly what you're showing here.
That's garbage wood, right? And that's low strength wood. I think we looked at those as being like some number 3, there's some number 2, there's stud grade.
Yeah.
So that's kind of like a mix. My hypothesis is, could you theoretically, if you can reinforce it better, and use some of that metal properties in there, use lower grade fiber to get similar values in a beam?
Theoretically you can, because it's you're compensated for the style.
Yeah. As we were preparing our mock-up for testing, we asked Sobi his hypothesis on the failure mode of our test beam.
In beam failure, you're technically going to have like a sudden catastrophic failure, like a crack line or a finger joint line. Do you think that this would change that to a more gradual failure mode?
That's the thing. It will be more ductile for sure. That's the good thing about the steel. Because timber is brittle failure, but with that, it will give you some warning, which is actually good.
Yes.
From a behavior perspective, like you don't get a sudden failure. Something will give you a warning first.
Yeah.
Now, it's time for the strength test to see how much pressure it takes for this mock-up to fail and break.
Good. Okay.
43. That's kilonewtons?
Kilonewton. What about, let's look at the deflections. 10 kips, yeah.
Is that good?
The maximum, the ones that we did before, but again, this one is different. We got, I think, 19 with the maximum.
The test showed us that GripMetal does enhance the strength of low-grade fiber in beam applications. But these are just early results. That's why the next phase is critical. We're already working to create full-scale reinforced beams with GripMetal and testing them against industry standards. But to get there, we need the help of mass timber manufacturers, architects, and engineers who are willing to innovate and push new technology forward. If you're interested in learning more about the benefits of GripMetal and mass timber, visit reinforcedwood.com to schedule a call with the GripMetal team.
If somebody watching this right now wanted to explore working with GripMetal in their systems and in their products, what should they do?
They should reach out to me. We have a full R&D facility here. We're willing to work with clients to bring the next generation of product to market. So reach out and we can work on a test plan and build the next generation of product.
As we concluded our tour, one thing is for certain. Mass timber is growing. And as mass timber pushes towards taller buildings, longer spans, and more efficient fiber usage, it's innovations like this that will push the industry forward.